this initial discussion. So we have seen different kinds of locks, how they work, how the requests for the locks are being granted, right? So based on all those concepts, the lock-based protocols are designed. So we are going to discuss now the concurrency control protocols, which are known as lock-based protocols. So this is the very first category of the protocols. Those are being used for concurrency control. So in today's session, we are going to focus upon only lock-based protocols. Right? So far what we have observed, if we are not having any locks, so if no locks are being used, or if data items are unlocked as soon as after reading or writing them, meaning once we have used that data item, we have unlocked that, or if at all no locks are being used. In both these situations, the inconsistent states of the database may result. The second observation is that if data item is not unlocked before requesting a lock on another data item, then deadlock may occur. So if data item is not unlocked before requesting a lock on another data item, then deadlock may occur. So these are our observations. So a lock-based protocol is a set of rules followed by all the transactions while requesting and releasing the locks. So locking protocols actually restrict the set of possible schedules. So whichever are the schedules, those are being generated. Those schedules are generated following this lock-based protocol. So what is lock-based protocol? It is a set of rules followed by all the transactions while requesting and releasing the locks. So locking protocols actually are restricting the set of possible schedules. Right? So let us see few important terms or terminologies with respect to this locking protocol. So we say that schedule S is legal under a given locking protocol if S is a possible schedule for a set of transactions that follow the rules of the locking protocol. So if I am having several transactions, say T1, T2 up to Tn, right? And if these transactions are participating in a particular schedule, say S, then we say that this schedule S is legal under locking protocol if all these transactions are following the rules of locking protocol, right? And locking protocol ensures the conflict serializability if and only if all legal schedules are conflict serializable, right? So let's see now one more pitfall of locking mechanism. As we mentioned, deadlock may occur in case of locking mechanism. Also, another problem is the problem of starvation. Once again, you might have used this term in operating systems. So what we mean by starvation? Starvation is also possible in case of badly designed concurrency control manager, meaning a transaction may be waiting for exclusive lock on an item while a sequence of other transactions request and those are granted the shared lock. So in this scenario, the transaction who is asking for exclusive lock on the data item has to wait for long time. Why? Because meanwhile, many of other small transactions are requesting the shared lock on the data item and these shared locks are being granted to these transactions. So all these transactions who are asking for shared lock on the data item, they may proceed. But as other transaction wants to have exclusive lock, that transaction needs to wait. So this situation is known as starvation. So the same transaction is repeatedly rolled back. Right? Many times. It may happen that the same transaction is repeatedly rolled back. Why? Because there is a deadlock occurred in the system. So once again, whichever is the transaction that is repeatedly rolled back, that is experiencing starvation. So the concurrency control manager need to be designed to prevent such kind of starvation of the transactions. Right? So, how we are going to avoid this starvation? The locks should be granted in some predefined way. So, how the locks are being granted? When transaction TI is requesting a lock on data item Q in a particular mode, say M, then the concurrency control manager grants the lock only if there is no other transaction holding a lock on Q in a mode that conflicts M, obviously. So this has to be done. And what is the next condition? This is most important as far as avoiding the starvation. There is no other transaction that is waiting for a lock Q and that made its lock request before TI. So if there is a transaction TI who is waiting for lock Q on the same data item and that lock request has made earlier, then the transaction who is requesting the data item after the first transaction has asked for it, that transaction who is asking for it later will not be permitted. And this is how the starvation of the transaction can be avoided. Right? So this second condition is really very important. So let us go to now a two-phase locking protocol. Two-phase locking protocol. So what is this protocol? In this protocol, actually we are having two phases. The first phase is growing phase and the second phase is shrinking phase. So what is happening in growing phase? Transaction may obtain the lock, any kind of lock. So transaction is allowed to obtain the lock. But the transaction is not allowed to release the lock. So in growing phase, transaction may obtain the lock, but transaction may not release the lock. In shrinking phase, exactly opposite. Transaction is allowed to release the lock, but transaction is not allowed to obtain the lock. So these two phases are known as growing phase and shrinking phase. And by following these two phases, this protocol known as two-phase locking protocol is designed. So this particular protocol ensures conflict serializable schedules. So what we mean by that? If this protocol is followed and if the scheduler is generating a schedule, then always the schedule that is being generated by making use of this two-phase locking protocol is always conflict serializable schedule. Always. Right? So this two-phase locking protocol ensures conflict serializable schedules. And that is what is our need. Right? So see here one example and tell me whether these transactions are following two-phase locking protocol. In two-phase locking protocol, we are having the growing phase and we are having the shrinking phase. What happens in growing phase? The transaction obtains the locks and they are not allowed to release the lock. In shrinking phase, they are allowed to release the lock, but they cannot obtain the lock. So please tell me whether these two transactions T1 and T2 are following this two-phase locking protocol. Yes. What is happening in T1? It is acquiring lock, meaning it is in growing phase. Right? And whenever the transaction unlocks the data item, it enters into shrinking phase. So once it has entered into shrinking phase, then the transaction is not allowed to acquire any lock. But here in this situation, this transaction once again is acquiring a lock. So this transaction T1 is not following the two-phase locking protocol. Here also in transaction T2 has acquired the lock. So in growing phase, here T2 has released the lock. So it has entered into shrinking phase. And once again, after entering into shrinking phase, it is asking for acquisition of lock. So once again, this is not allowed in shrinking phase. Right? So this transaction T2 is also not following the two-phase locking protocol. I hope you must have understood the concept. Once the transaction enters into the shrinking phase, they are not allowed to acquire any locks. Right? So both of these transactions are not following two-phase locking mechanism. If we look at these two transactions T3 and T4, now please tell me whether they are following two-phase locking protocol, whether they are following two-phase locking protocol.
Yes.
Yes, and the reason is, see here, acquisition of lock. So this is the growing phase. And here unlocking. So it has entered into shrinking phase. So no more requests for locks are after shrinking phase. So this is following two-phase locking protocol. Similarly, this transaction is also following two-phase locking mechanism. So I hope now you must have understood this concept. Okay, now the rules those are governing this protocol are listed here. Two transactions cannot have conflicting locks. No unlock operation can precede a lock operation in the same transaction. No unlock operation can precede a lock operation in the same transaction. No data are affected until all locks are obtained. That is, until the transaction enters into a locked point. Right? So these are the rules. Right? Those are followed in this protocol. So see here, pictorially, what happens in two-phase locking protocol. So at this instance, the transaction has started. So transaction is acquiring the lock, acquiring the lock. So till this point, the transaction is in growing phase. After acquisition of all the locks, it enters into the locked phase. So whenever the last lock is being acquired, it enters into, or this point is known as locked point. So at this point, all the locks are being acquired. So after acquisition of the last lock, the transaction or this point is known as locked point, and the transaction is entering into the locked phase. So during this locked phase, the operations are being performed, right? And after performing the operations, the shrinking phase comes in. So all the locks are being released in this shrinking phase. So this is a pictorial interpretation of two-phase locking protocol. Right? So I hope you must have understood this concept of two-phase locking protocol. Now, let us see few important points related to two-phase locking protocol. As we have mentioned earlier, this protocol assures serializability. And it can be proved that the transaction can be serialized in the order of their lock points. So I just mentioned what we mean by a lock point. That is the point where a transaction acquired its final lock. Right? But the drawback of two-phase locking mechanism is it does not ensure freedom from deadlocks. So in two-phase locking protocols, deadlocks may occur. Deadlocks may occur in case of two-phase locking protocol. Also, cascading rollback is possible under two-phase locking. So what is the advantage of two-phase locking protocol? It assures serializability, right? But the drawback is we may have the deadlock and the cascading rollbacks are possible in two-phase locking, right? So see here what we mean by cascaded rollbacks. This is T5, this is T6, and this is T7, right? So what is happening over here? T5 is reading data item A, having the exclusive lock. On data item B, it is having shared lock. So reading A, reading B, writing A, and then unlocking A. Right? T6 locking, requesting an exclusive lock on A. As T5 you have unlocked this lock, T6 can be granted this lock. So T6 is reading A, writing A, unlocking A. Right? Now, what T7 is doing? T7 is requesting now the shared mode lock. So as T6 has unlocked this lock, T7 can be granted this lock. T7 is reading and doing some operations. So if there is a failure in T5 after this point, then what will happen? All these transactions need to be rolled back. Right? All these transactions need to be rolled back. So in case of two-phase locking protocol, the cascaded rollbacks may happen. Right? So after this read A of T7, if there is a failure of transaction T5, then what will happen? T5 needs to be aborted. So as a consequence, T6 is also aborted, T7 is also aborted. Right? So cascaded rollbacks are possible in two-phase locking protocol. Okay? So to avoid cascaded rollbacks, the modified version of this protocol exists, and that is known as strict two-phase locking. So here a transaction must hold all its exclusive locks till it commits or aborts. So till the transaction commits or aborts, all the exclusive locks are held with that transaction only. And this is a stringent condition that is being imposed in two-phase locking protocol, and that is why this is known as strict two-phase locking. One more variant of this two-phase locking protocol is rigorous two-phase locking. Rigorous two-phase locking is more stringent than the strict two-phase locking. In rigorous two-phase locking, all locks are held. So even though it is exclusive or shared, all the locks are held till the transaction commits or aborts. Right? So in strict two-phase, only exclusive locks are held till end, till commitment or abortion. But in rigorous two-phase locking, all the locks, shared as well as exclusive locks, are being retained till the transaction commits or aborts. So these are two variants of two-phase locking protocol. Right? Now, this is the last concept that we are going to discuss now in today's session. See here, we are having this two-phase locking protocol, okay, and we are having two transactions T8 and T9. So T8 is reading the data items A1, A2 up to AN, and at the end T8 is writing data item A1, whereas in T9, T9 wants to read only two data items A1 and A2, and T9 wants to display the summation of A1 and A2. If we are using this two-phase locking protocol, then what will happen? If we are using two-phase locking protocol, then as we want to write this data element A1, we want to acquire exclusive lock on on A1. Why? Because A1 we want to write it, right? So T8 will lock this A1 in exclusive mode. Others can be locked, other data items can be locked in shared mode, right? Here T9 wants to read A1 and A2. So T9 wants to lock A1 and A2 in shared mode only. Correct? Now, if we are using two-phase locking protocol, then every transaction must follow two phases, growing phase and shrinking phase. So unless this exclusive lock is unlocked, right, it is not possible to lock that data item by T9, right? So T8 must lock A1 in exclusive mode, and any concurrent execution of T8 and T9 should lead to a serial execution only, because at the end of this transaction A1 is being written and it is having exclusive lock. So as A1 is having exclusive lock, this T9 cannot proceed, right? So the observation here is T8 needs this exclusive lock at the end, because at the end of the transaction this T8 is writing this A1. So exclusive lock is needed at the end only. So if initially A1 is locked in shared mode, then that will be okay, because initially T8 is only reading the data item and not writing it. Right? So why not to apply initially this shared lock on data item A1, and why not to convert that shared lock into the exclusive lock at the end whenever it is required. If we do that, then obviously we may observe more concurrency, right? And the same concept is being devised in the next variant of this two-phase locking mechanism, and this protocol is known as two-phase locking with lock convergence. Two-phase locking with lock convergence. So what we are doing here, no doubt we are having two phases because it is two-phase. So in the first phase, we can acquire shared locks on the data item. We can acquire exclusive locks on the data item. Also, we can convert shared lock to exclusive lock. And this method is known as upgrading the locks. So shared lock gets converted into exclusive lock. In the second phase, we can release shared lock, we can release exclusive lock, and also we can downgrade exclusive lock to the shared lock. So this is only the difference. Okay, so in this two-phase locking with lock convergence mechanism, it is possible to upgrade the lock in first phase and downgrade the lock in the second phase. So this protocol assures serializability, but it relies on the programmer to insert the locking instructions in the transaction, right? So upgradation and downgradation of the locks is possible in this protocol, which is one variant of two-phase locking mechanism, right? So see here, lock conversion, how we are going to do that. See here, the same transactions, those we were talking about. Shared lock on A1. So T9 also asks for shared lock. So T9 also can proceed. Then this T8 asks for all the shared locks of all the data items till this last data item, right? So T9 is asking for shared locks. T9 reads these data items, displays the data item or summation, and unlocks this A1 and A2. And then what T8 is doing, T8 wants to write now this A1. So T1 upgrades the lock on A1. So earlier the lock was shared lock. Now T8 upgrades this lock so that now the lock will be exclusive lock. Right? So here we are having the instruction upgrade the lock of A1. Right? So this is how lock conversion takes place. Okay? So this is regarding the lock-based protocols. How actually the implementation of locking is being performed in database management system, that I'll be covering later. And then we will go for the remaining protocols.